So geographic information systems is supposed to take a central database and tie it to a map to give information to the staff or public. They're often done by the lowest bidder with vague information to work from. So their data of their map and their database is only as good as the original data, but then there's another layer to get it into the map. So we're going to talk about excessive data. In theory, because the center of a curve only has 1 point, it should only add at most 3 points for each one of those 9 lots. So in Pontiac, Michigan, Oakland County, one of the wealthiest counties in the United States, they have a GIS map. This is Pontiac, Michigan, and a site that I'm involved with working in personally. So how many points do you think it takes to draw 9 lots? Well, it takes 670 points. And why? It's because ESRI and a lot of the GIS systems cannot draw an arc, which is ironic because it's called arc info. So if it draws an arc, it needs a series of tiny little lines to draw the curve because it can only draw a polyline. The more of these tiny little lines to draw the curve, in theory, the more accurate the area can be. However, because ESRI subscribes to rubber sheeting and stretching the maps in all different directions, none of these points are actually along a curve, but along a parabola. So when we take a look at the small area that I wanted to work in, there was 160,000 points in that one accurate line. So when first introduced in the 1970s, GIS did not work on fast computers. Computers were pitifully slow. So the only way you could get speed is to create a polyline or a line that went through a series of coordinates. And that polyline was closed, which would give it area. So if you draw a curve, it took a tremendous amount of time because of the calculations, because the computers were slow. So the solution was to eliminate the curves. Yeah, that may have made sense 40 years ago, but certainly not today. So on the site that we worked in, I overlaid the GIS data with a very accurate aerial data to trace, take and trace the elements that I needed on the design, and we found an intersection that was off by 40 feet, and pretty much all these other areas were off by quite a bit. So the problem is the developers that build in the city will assume the data is reliable and might make bad decisions. Well, is that a wetland? Maybe, maybe not. Is that data right or wrong? So they go to, before they buy a piece of land, they might go to the city's GIS data and query it, and unfortunately they may decide to buy a bad piece of land because the data is bad, or they might walk away from a good piece of land. And here's the problem. Most architects and planners assume the data is reliable. It's not. So what happens is the surveyors and engineers that get data built off the GIS from architects and planners, as soon as they see a wrong number and their liabilities based on it, they throw out all of the data. They say, yeah, it's just planners and architects. I'm going to do my own thing. And that reinforces a lack of communication between these professionals. So it creates the uncollaborative industry that plagues land development. So all of these are important. Sometimes the topographical data will come from LiDAR. So when you take a look at this spastic map, why is that even acceptable? Cities and consultants just throw that back at the aerial mapping companies that produce this garbage and refuse to pay for it. Can you tell where the street is on this? Well, that's the center of the street, and those are the edge of the pavement. You cannot use this for any kind of detailed planning. It's total trash, and it's not even remotely accurate other than a general surface. Yet, when you look at this, that data, you can see on the right side, I took a little area there, to edit this data. This data is almost 100,000 points. It would take a person in engineering who really cares about his work about a day to filter this out before it's even usable. How did the industry get this bad? And that data, that will show up as a polyline in the GIS data. And here's a 100-year-old map. This data is probably more reliable than that squiggly garbage of the LiDAR data, because LiDAR takes a point like every 2 or 3 feet. The computers, the software can't handle it, or maybe the aerial mapping company didn't want to put their time into filtering that data. Who knows? But it's garbage. So when we take a look at a proper contour map, A proper contour map, you should easily see exactly where the center of the street is. You should see contour lines going from top to bottom of curb, and LiDAR cannot produce that type of data. So all of that would be missing because it can't take a point every hundredth of a foot. So what happens is a land surveyor went ahead and created the points for this contour map at 2-foot intervals. So how many points do you think that came off that data collector that's going to create all of this, not only the contour map, but the physical map? So take a look at this and figure out it's 2-foot interval. Okay, so it's 640 points. So if we draw the contours at half a foot interval, we see a lot more detail. And how many points do you think that took? Well, it took 640 points. Why? Because contour lines should not exist in CAD or GIS. Contour lines should be a physical, computational data that you could query, rough or smooth, any interval you want, anytime you want, to create a physical surface, and that is far more accurate and far more reliable than data overload. That's going to be part of your GIS problem. So the same 640 points define the physical surfaces. Look around you. We don't live in a world of polylines. We live in a world of surfaces, physical surfaces. And so everybody that's even remotely tied to the land development industry, you are in the business of surfaces. What's a surface? A piece of land someone owns, a natural surface, the surface of watersheds, the surface of soil types, the surface of physical buildings, lines and curves and things like that. That's just to create a drawing that could have been done 300 years ago. We're in a new era. We're thinking in terms of surfaces. GIS is partially on the way there by using shapes, but shapes are not accurate because of the problems I just explained. So we want to solve all of these problems. The same 640 points is used for the line work drawing. The line work represents surfaces, but it's precise because it came from the field. So what happens is GIS maps are partially traced in by the lowest bidder, which is going to be total garbage, and then over years they import CAD data to try and rectify that. But the problem is they've rubber sheeted this, so it's so bad. It's like, how do you fix this domino effect that is total trash? So this is part of the reason that we want to take a look at first with GIS mapping, with LandMentor, to solve these problems, and eventually get rid of GIS and replace it with LandMentor. So what we're doing is overlaying this image, same 640 points, the physical surfaces, the line work, and now you can tell a little bit better, a little bit clearer what these various elements are. The contours shown here are 1 foot, and again, we're talking about 640 total points. So with that, we could start querying the map for critical information that the developer and the cities can use for economic and environmental impacts. When you bought that piece of land, this is what you've bought, the physical area of everything. So if you have to rip out and improve something, it is shown here. So we need to provide useful data that CAD cannot provide because it's not spatial, and GIS cannot provide because it's not accurate and they don't have a curve. So once we have the 640 points, we could go directly into the 3D visualization just by giving some of the surfaces height, so we have a better idea of what the surface would look, or the surfaces would look like in a 3D view, to start visualizing contours. Is it going uphill, downhill? Of course, we all know red is downhill, green is uphill, but it still helps. And then we could go in, drop some SketchUp models where the trees are and people for scale, and then move about the site. And again, we're still talking about the original 640 points versus the 670 points that ESRI took to draw 9 two-dimensional lots. That is all bad data. And so this is the problems that we need to solve in the industry moving forward. So the rest of this video is really, we'll keep these problems in mind, is really how do we take garbage data and make it right, which is not possible, but what can we do to filter this data to at least determine is it usable and answer these questions. So this is the problems, and then we'll explain as we go more into this what the solutions would be to use the software to help solve some of these industry problems and actually make GIS data usable, whether you're using ESRI or not, and using this as a conversion, or eventually just replacing ESRI with LandMentor.